Then now here is a cantilever beam with a point load. Sometimes a point load has to be provided here. This is the column, this is a small cantilever beam. At this point you need to rest a point load like some let's say a point load has to be provided, likewise some trusses like this one, some trusses you need to be provided. The load is applying here. So actually this is the incorrect method of reinforcement layout. Actually it has a tendency to bend here like this one, in this direction it will tends to here. So to resist that forces, you need to additionally provided the top reinforcement like this one. The reinforcement is provided here like this direction at the top 2 or 3 layers, and the spacing and the shear reinforcement or additional reinforcement in horizontal direction is also needed like this one, and the spacing between these stirrups also should be more closer at this junction. Okay, this is the correct way providing the reinforcement, and the beam and the bottom reinforcement is extended to the column to get good bonding actually like this one. It is very important. It will ensure the column beam joint is strong and rigid. Otherwise there is a chance to have a crack like this one. A crack will be then the loading is applying like this direction, there is a cracks. So to ensure this one, the shear reinforcement, additional shear reinforcement is needed like this one, a horizontal direction. So if there is a point load is there, you can easily withstand that load also. If you need to provide a opening in a concrete wall, actually there is a more chance to have some cracks here. Normally we are providing the reinforcement in vertical direction and horizontal direction only. To withstand these cracks, the reinforcement in this direction is also needed like this one, in this direction at corners, you see. So the reinforcement is there, horizontal and vertical closed reinforcement is there, and near to this opening, the closed the spacing of should be very closed. At a horizontal direction also, the spacing of the horizontal and vertical reinforcement around this opening should be minimum, and in addition to this one, to resist in tangential direction also, in a inclined direction also, the additional reinforcement is needed to avoid the cracks. Beam column junction to exterior column like this one, you need to provide, this is incorrect method actually. The bottom reinforcement is extended to this column, the top reinforcement is extended to like this one. This is the normally we are providing the reinforcement at site. Actually this type of reinforcement layout is not correct. It is not sufficient actually. Instead this layout, this is the correct method. We are providing the reinforcement. So in addition to it is the column junction exterior column, it's exterior column, the beam is ends here, not continuous. So to ensure this column junction is more stronger, we need to provide additional reinforcement like this one. U-type reinforcement is U-type bars are providing here like this one. Okay, you providing U-type, bending to U-type. It is better to provide like this direction. Sorry. like this one to U bar. Actually it is parallel, as it is parallel lines, it is not shown here. This type of bars also should be provided like this one to, it should be extended to column. Okay, the splices detail for column, actually normally we are doing, this is the way reinforce, the top reinforcement is tilted like this one and is extended like this one. It is compression member. This is method is incorrect. This is the method. Actually the bottom reinforcement is spliced towards to column here, and this is the main additional reinforcement is continued to like this one. This is the method of reinforcement. Is one bar is tied together at this side, at this space. The lateral ties should be very closed. Lateral ties should be very closed at this region, at the junction of splices area. You see, this beam is continuous to either side. The column is here, the size is larger, above the column size is small, but the beam size is same, and it is passing through this column junction. The reinforcement in this junction is normally provided like this one. This is the incorrect method. Actually the reinforcement is passing, the lower main reinforcement is passing through this direction. The top reinforcement is also passing to this direction. The main column reinforcement is extended to up to this point, and it is bended towards this direction, both direction, as the column sizes reduces, and the reinforcement is similar way. But it is incorrect. Already you know that very near to the support, actually this area and this area, the shear force will be maximum. Actually to prevent that shear force, you need to provide these stirrups very closely. This is the most important mistake, that is most important mistake always the people committed at this site. To avoid this, this is the correct method. At shear region, the lateral ties, means the stirrups are provided very closer span. It should be less than 75 mm like this one. And not only in horizontal direction, in vertical direction also, means the lateral ties in columns also at very near to the column beam junction, the spacing should be minimum, because the lateral forces are, we consider expected that the lateral forces are hitting at this joint. If this joint is weak, the total structure will be collapse. So each and every column beam junction should be sufficiently strong to ensure that we needed to take some care like this one. So the splice, if the column is not continuing to vertical direction, termination of column bars inside the beam, the column bar is extended to this direction, and other reinforcement from this side is extended to this direction. This is the correct method. Actually the reinforcement to overlap here, actually the reinforcement coming from one side is to up to extended to up to this direction. Here this is incorrect method. It is not extended to this direction. So this is the incorrect method, this is the correct method. And column beam junction, actually earthquake region, beam column exterior, and you see this column is continuous in vertical direction. The beam is coming to end here. Actually the reinforcement, the top reinforcement from the beam should be extended sufficiently to the column, and the bottom reinforcement also extended to upward direction. This is the correct method. The bottom reinforcement is extended to the column in upward direction. the top reinforcement is extended to bottom direction. It is extended to below this, and the splice means, and at this region the spacing of stirrup holder is minimum. Okay, this is the correct method to provide earthwork region beam column junction. This one, and footing depth, the people are not aware how much length should be extended. That actually that much length is development length. It should not be less than 300 mm, whatever may be the size, and it should be minimum 300 mm. This area is main reinforcement confinement. To ensure the fixity, we need to provide these lateral ties very closer here. This is the way the reinforcement actually we provided, column bars actually provided. In staircase, this is incorrect method. The bottom reinforcement coming from this side and it is continues to this side, but instead actually the bottom reinforcement is extended to the top of the waist slab. It is extended to waist slab like this direction, and the bottom reinforcement is extended to the top of the landing slab. This is the correct method. Okay, in addition to an additional bar is also provided to middle of this area. This is the way the staircase with the waist slab, the actual reinforcement. Always normally the unskilled laborers are providing the reinforcement like this one. Actually there is no connectivity will be the waist slab and landing will be very weak, the connectivity here. So to make sure that the slab, the waist slab and landing slab should be sufficiently strong at this junction, for that the reinforcement should be like this one. Sometimes in the slabless staircases there is no waist slab. The slab is this direction. This is the new trend of the reinforcement, providing some unskilled laborers. The reinforcement is bending like this direction and providing the reinforcement. This type of reinforcement layout will not take any load, actually no use. It is utter nonsense actually providing the reinforcement like this one. This is the correct way the reinforcement is provided. Actually each and every junction actually act as a beam. So this is the correct method. The bottom reinforcement is provided like this direction, and it is provided a beam like this. This is the correct method. We providing the reinforcement, bottom reinforcement bending to here. The top reinforcement is providing to like this direction. This is the way method providing the reinforcement. You see the main reinforcement like this one and this one. This is the method, and it is providing like this one. Another alternate method is also like this one. You can provide the reinforcement bottom to here and starting to here, this one like this one you can provide. The top reinforcement also can be provided like this one, the separate reinforcement. This is an alternate method to provide slabless staircase. Okay, that's all. These are the main I think this is the most important things and elements that people always commit a mistake. I invite your attention to these topics when you are working as site engineer at your site. At least on these points you keep some attention to provide the reinforcement accurately. You can avoid major issues at the sites. Actually, if you committed some mistakes, actually it's out to open. All the people can see what mistakes you have commit. You cannot cover this mistake. You can't cover your mistake. So it's open. Once you have committed a mistake, it's a mistake. It's ever forever. So there is no alternative to cover this mistake. So it is very important. What is the right way that you are doing in your site is very important. You must understand what is the right, what is wrong. That is why I given some example for you to understand what is right or wrong. Thank you.